Sorry. There we go. Intro. So, hi there. This is Jacob Nash, Algebra Lessons. And this is Unit 1, Lesson 7, on Order of Operations of Functions. So, I apologize for the delayed intro. I accidentally turned off the last video that I was making and pushed it 2 times, so it made it think I wanted to do it already. So, order of operations of functions is pretty simple. So, just like how we have order of operations of numbers, where it's just like, if you have something like this, you do what's in the parentheses first, things like that. But that's the same case for the, for functions. So, the different ones that there's addition, subtraction, multiplication, division, and then there is composition. That is something interesting that you've maybe never seen, but we'll get to that. So those are the 5 ones we're going to be looking at. Let's start out with addition. This is pretty easy. So let's say we're given that fx equals 2x plus 3, and gx equals 4x plus 1. And it's saying, what is fx plus g of x? All we have to do is substitute fx and gx with 2x plus 3 and 4x plus 1, and then just have an addition in the middle. That's what you do for any of the order of operations. But you have to consider some things for the other ones. Really, the addition one is easy. So we have 2x plus 3. We substitute that in for fx, plus 4x plus 1. That is what we substitute for gx. So we need to add like terms. So we first add those, and we get 6x. Then we add 3 and 1, and we get plus 4. So that is what fx plus g of x is. It is 6x plus 4. Simple. Now let's look at subtraction. Now you need to pay attention for this one because it is easy, but there is one thing that you need to... Well, I shouldn't have erased those values. Let's just keep the same values. Fx equals 2x plus 3, and then g of x, equals 4x plus 1. Let's just keep those same values. When you're subtracting, there's something you have to take into consideration. So let's say now we need fx minus g of x. So we still substitute in the values. So that would be 2x plus 3 minus 4x plus 1. Or sorry, plus. Now, whenever there is a negative beside a parenthesis like that, you're going to need to distribute it. And when you distribute a negative, anything that's in the parentheses changes what sign it is. So if it was positive, it goes to negative. And if it was negative, it goes to positive. But we have both positive for the 4x and 1, so they both turn negative. So now we have 2x plus 3 minus 4x minus 1. Some mistakes students might make is think only 4x needs to be negative, but that 1 needs to go negative too. But if it was negative 1 to start with, you would change it to positive 1. So now we can simplify by combining like terms. We have 2x minus 4x, which is negative 2x, and we have 3 minus 1, which is plus 2. That's how you do subtraction. So pretty simple, but you just need to remember that the negative changes what is to the right of it and makes all the things change what sign it is. Not necessarily just go negative, because if it already is negative, then it needs to go to positive. So now, let's look at multiplication. So, there is a couple different ways to go about this. So let's say we have f of x times g of x. What do we do? So we plug them in. But you can't just say like 2x minus 4 times 4x and then 3 times 1. No. You have to do... there's two ways to do it. I'm only going to show one way because this way is the most simple and it takes the least time, in my opinion. There's box method, where you would draw a box like this, and there would be 4 different places. So you have 2x plus 3, 4x plus 1, and then you would multiply each thing that goes in the box. But that's not really something I'd like to do. That might have been the way you were taught before, but I like to use something called FOIL. So FOIL, maybe you've never heard of it, but that is an acronym for certain things you have to do when you're multiplying these different functions. So F stands for first. Let me actually just do this. Okay. So I'll make the F blue, the O green, the I red, and then the L yellow. So F means first. So these are the first ones in each function, the first parts of each function. Then, so you first would multiply those. Then you would multiply O, which means outer. So the outer ones are 2x and 1. See, they're on the outer part of the parentheses. And then I is inner, so these are the inner. And then L is last, so these are the last two ones. So that's what order you multiply the things in. So first we have the first ones, and that's 2x and 4x. So when you multiply an x, when you add an x, it just stays x, and we would do 6x if we were adding them. But we have to multiply, so we do 4 times 2, or 2 times 4, which is 8, and x times x is x squared. Then we have outer, 2x times 1. Anything times 1 is itself, so we just keep that as 2x. Then we do the inner, 3 times 4x. That would be 12x. And then we do last, 3 times 1. Once again, anything times 1 is itself, so it's just 3. Now we combine like terms. Nothing goes with 8x squared, so we keep that as it is. These can combine, so 2x plus 12x is 14x. And then 3 can't go with anything, so it's like that. So that's what the answer is to this. So that's the easiest way to do it, in my opinion. Now, I would use the box method if there was more than 2 terms in the parentheses. In that case, I would. But you just have to think of every combination. You have to multiply every combination possible of these numbers. And so that's why you have to do that. Okay, so that was multiplication. That was a little bit more complicated. Now we have division. So what happens if it's division? So let's say we had fx divided by g of x. And sorry that I said fx, I meant f of x. That's how you actually say it. So now we just substitute in. So we have 2x plus 3 divided by 4x plus 1. Really, this isn't that hard. All you have to do is, well, actually, in most cases, you would just leave it as it is. So we would just leave it as it is, because really, I mean, you could try to simplify this, but in most cases, you just leave it as this is. But there is something you're going to need to do. You need to think of it. You'll be required in algebra to come up with a an equation that is not true for g of x. What could g of x not equal? And then we're going to eventually find out what does x in g of x not equal. And there is one situation where this would be false, because if you think about it, any number divided by 0, so n over 0, is going to equal imaginary or undefined, because that is not a thing. There is nothing that can be divided by 0. Things can be divided by 1, and a 0 can be in the numerator, but anytime there's a 0 in the numerator, it's always 0, but it cannot be in the denominator. That is a false math statement. So what you have to do is say that 4x plus 1 cannot equal 0. It cannot, or that would be fake and it would not be true. So you need to figure out what x is. We can subtract 1, and then 4x does not equal negative 1. Divide by 4, x does not equal negative 1/4. If that's what it did equal, then it would make it 0, and that would be fake. So that's all you have to do when there's division. You just set it up by substituting it in, and then you have to find the value that would make it not true. You just always take the expression on the numerator and set it not equal to 0, and then solve. Alright, the last thing that we're going to look at, well, for the first part of the video, we're also going to look at if we had a number put in, but we'll look at that in a minute. So, what is this? You might think that looks like a multiplication thing, but that's not what that is. We can use this for multiplication when it's colored in, but when it's not colored in, that's called composite. Now, you need to pay attention, because once you understand this, it's simple, but it might be a little bit confusing at first. So what would we do if we were trying to find what f of x composite g of x is? What would we do? Well, we actually have to place g of x into the x of f of x. So basically, you are substituting in for x, whichever function comes first. You put the second function in the place of where x is. That's all that means. So we do 2 times, so we need to substitute in for x, 4x plus 1, that's right here, and then plus 3. You would then distribute, and we get 8x plus 2 plus 3, and then we get 8x plus 5. So that's all that is. That's what that means, okay? So that's pretty simple. Hopefully that made sense. Now we need to look at what would happen if we had values put in for that. So let's see. So we still have those. This is given, but what if we were required to find f plus g, and then we have 2? What does that mean? That means we need to add f of x plus g of x, which we already did in the lesson. And if you remember, we got 6x plus 4. Now, what the 2 means is that you plug that into x. So 2 is plugged in, and then we get 12 plus 4, which is 16. So f plus g of 2 equals 16. So there you go. That's what that means. So that's what you do whenever there is a question like that. You just do what we did earlier in the video, and then you have to substitute in that number for x. Let's look at another example. So let's say we had f divided by g times 5. Okay, now we need to do 2 times 5, we're plugging in for x right there, plus 3 divided by 4 times 5 plus 1. Then we get 10 plus 3 divided by 20 plus 1. Then we get 13 divided by 21. And that would be our most simplified answer. So there you go. That's what that would be. Let's actually, the last thing we're going to do, let's change this 5 to a different value. Let's make it negative 1/4. So we plug that in. We get 2 times negative 1/4 is, negative 1/2. We'll just say negative 0.5 plus 3 divided by, that turns out to be negative 1 plus 1. So then we get 2.5 on here, and then we get 0 on the bottom. Uh-oh. Let's see what happens in the calculator if we do that. It says cannot divide by 0. That's what I already said, and if you maybe already caught that, I did that on purpose just to see. But this would be an answer that is undefined or imaginary. It's not a thing that there actually is. I mean, if you think about it, it kind of makes sense why you can't divide by 0. Because when you first learned about division, maybe in elementary school, they had like, let's see, can have brown. So you have like cookies. Yeah, let's just say you have 3 cookies, and then you have 3 people that want the cookies. What do? You do 3 divided by 3, and then you get 1. On the top, you say how many of the thing that there is. There's 3. And on the bottom of how many people there are, 3. But if you have no people, 0, that is not a thing, because what's the point? I mean, if you have no people that want the cookies, you can't divide it. You can't divide it, because that's not even a possible situation to solve for. So that's the reason for that. And that would wrap up our order of operations for functions. And I'll see you on the next video, lesson 8, on the inverses of functions.